YouTube. You can pull. You don't have to watch the whole movie. So yeah, definitely something to think about there. This is another reason why I do this. Okay, so blabbering on here. I already went through this with the class here, but I do this too. I'm like, wait, I don't really see something factorable here yet. I don't know. I'm looking at this and it doesn't feel factorable. So I'll still do an MA check, and I'm not necessarily would write this down, but I would think, okay, the M number is 26. The A is always the middle term. Is there any numbers that do that? Multiply 26 and add the positive 4? It's impossible. It's not even close. So I do that to see if it is factorable. And if I do have a combination of numbers that work, then I do unfoil. But I've been doing this forever. It really depends on your math level, but that tells me it's not factorable, so I must go to the quadratic. Oh, I'm sorry. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's fun. All right. Now I'll tell you why I'm going to do what I do next, which is going to be stop. I'm going to stop this question right in the middle of evaluating or simplifying. First things first, we should understand that two negatives do cancel, but I'm left with a negative. So this is going to be a negative product here. And then 4 times 2 is 8. 8 times 13 is 80 and 24. So negative 104. I'm going to tell you, I'm going to stop here. I'm not even going to add these. Because for the purposes of doing this question, what kind of solution is this? It starts with an I. 3, 2, 1, go. Imaginary. This is, and you don't have to write this. I'm doing this for note purposes. These solutions are imaginary, which means what for x-intercepts? There aren't any. So that means there's no x-intercepts. Now, how many do we have here? What's the number on this class? I have 25 in my last one. I thought this was more, 27. I got to remember that. So 52. I always need 52 copies. All right. I always go down and make copies. Like, geez, how many do I have? And I can't remember. And then I end up with extra pieces of paper. I don't like doing that. So I do those little half sheets. Save the trees, right? That half sheets that we've had for homework in that quiz. By the way, I'll have that quiz to you Monday. We'll use that as a learning tool for Wednesday, Thursday's test. Absolutely. We got a test next week, and since both days are shortened, we're going to split it up into 2 days. They'll be absent on those 2 days. And then we have Friday off next week, our first day off in probably like 20-some straight days of school. So, hey, who's student number 26? We got this last row here. Patricia, are you ready? Are you here? Okay, good. All right, so what was I going to ask? Which direction does this parabola go if I were to graph it? Up or down? Down. What's the y-intercept? All right, this will help me on what I understanding how to answer this inequality. What's the y-intercept? So you plug in 0 for x. Gone. What's the y-intercept? I just kind of showed you. 0, comma, negative 13. So this tells me, and I actually should have known this ahead of time, not even looking at the y-intercept, but the y-intercept solidifies my next concept. This parabola is going down, and it has no x-intercepts. So I should know that this exists completely below the x-axis. No x-intercepts, graph shaped downwards. I mean, come on, it can't be above the x-axis, then there would be real zeros if it was going down and it was above, right? Okay, so Patricia, what am I looking for this solution set? The graph above or below? The parts that are above or below? And I just highlighted what makes that important. Above. And is this graph above ever the x-axis? Yes or no? No. Or input, output. These outputs are all going to be what? Fumble. These outputs are all going to be what? And it starts with an N. 3, 2, 1, go. Negative. Negative outputs can never be greater than 0. So therefore, what is the solution for this inequality? There isn't one. There isn't one solution that can satisfy that inequality up there because the outputs are all negative when I plug in certain inputs. So that's what I wanted to have happen in your homework. And that's why I stopped. And you must understand, I don't really care what these zeros are anymore. This tells me I have no x-intercepts, and therefore I have to think after that. What if I had this? What if I had this question? Same situation, but it said greater than, or even greater than or equal to. It doesn't matter. I'm sorry, less than, my bad, dogs, or less than or equal to. What's the answer to that now from the previous analysis? All, come on, guys, all real numbers. It's the same reason why this would be all real numbers. Every input that I put in, I get a negative output, and a negative output is always less than 0 or less than or equal to, even if I threw that in. So this is all real numbers. All right, and I do want you to write that down somewhere. So special cases, you gotta think. You can't be a robot and you gotta get the x's, and then you gotta have some sort of mathematical process in your head as far as analyzing this correctly. Okay, go ahead and turn in that sheet now, which is not a sheet. It's a your separate sheet. I had you do it on a separate sheet of paper. All right. What are you doing with your gift? Okay. What's going on? Come on, let's roll. What's happening? Ready?
Thank you.
We're live here. This is on YouTube. We're passing in the papers. Okay. All right. Let's get a next student. Excuse me. Enter. Can't wait till this day's over. Anyone? Long week. Ooh. How many people are going to the football game? Raise your hand. Nice. I think that's also added up here. My girls are both a freshman and a junior. Well, Manuka High School, the team isn't so good, actually, right now. But you guys are fortunate. You guys know 4 years ago, what was the football team's record? Just 4 years ago. Oh, and whatever. We didn't win one game. All right, that was literally just 4 years ago. And then 4 years ago, we hired Mr. Chart. So this is only, I think, his third year being head coach. Is that right? Because I think it was 4 years ago. We were and whatever. So, and in 3 years, we're already where we're at because of him. I'll tell you the story about him. He actually was our defensive coordinator. Our last state championship was either 02 or 03. I just saw it and I forgot which year it was. And then he's been, I've known him since the mid 90s when I was working at Providence. And so he wanted to be a head coach. So he ended up being head coach at Lincoln Way North. Anyone know what happened to Lincoln Way North? It shut down. So actually he was head coach there, making that program great. Shut down. They had 3 head coaches already in place at the other 3 Lincoln Ways, so he had to go back to an assistant. And then we brought him back here, and the rest is history. That guy is something else, man. He knows what he's doing, for sure. So very exciting time for that. It's always fun when you have a real strong football team. So have fun there. I was going back to my daughters. They were going to the games early, but our Manuka team stinks. So now they're like, I don't know if I want to go to the game or not. So it does make a difference. It really does. Okay, so did I get somebody? What was it, 12? Nice, Jessica. Graph this first line. What's the y-intercept? All right, I'd mark you wrong so quick your head would be spinning. It's 0, comma, right? All right, so if you had to write that down, but y-intercept. But some people put it on the x-axis, and I don't know what to do about that. Now what do I do about negative 1/4? What's my next action? Good. Now, you could also go up 1 from this original position. That's positive 1 up, but then left 4, that's 1 over negative 4, right? You have those options either way. And I'm going to do that because I know what happens with our answer coming in. Well, I think maybe I'm wrong. I already forgot what happened the other hour. Then do the other one because it's simple stuff. Now, yell at my seniors. We're actually having a quiz today, and they have to do an equation of a line again. Find the slope and y-intercept and find the equation line. Because if a senior walks out of Lockport and they don't know how to do lines and they're in this college algebra trig class. That's absolutely ridiculous. So go ahead. What's the other line? What do I have to graph? Well trained. Nice. And then what do I do for 3/4? And I did remember correctly. Or I could go down 3, that's -3. Left 4, that's -4. -3 over -4. Whoa, Mr. Samuels, that's not a very good line. All right, and the reason I did that is, yes, these land at a nice, perfect coordinate where they cross. So what are we doing? We're solving systems, and I know you did this before. 1, 2, 3, 4. And I know when you first did this, unless your teacher skipped it, the first way you solve system is by graphing and then seeing where the graphs intersect. Right? Correct? Now do you remember this? Right? You lied to me yesterday. Someone still shook their head no. I don't know what happened with you in whatever class you were in. Right? Definitely this is something that has happened before. All right? But whatever. We're going to teach it like it's brand new anyway, and you better get on board immediately. By the way, graphing is the worst way to solve a system. Two simple reasons. One is this doesn't have to be a nice perfect whole number. 2 lines can cross at a decimal coordinate. It'd be impossible to find out what that decimal is if you didn't land smack dab, at a specific nice integral set of coordinates. Then the other reason is, what if these 2 lines cross at -100, -152, which is a coordinate? Would you want to be graphing and trying to find them cross that far away on a coordinate plane? Heck no. So then you learned other methods. This is why I picked substitution for number 2 if you look at the directions. It's ready. All right, and this is about the only time that I use substitution. I actually like the other method better, which I'll cover in 3 and 4. Substitution is good because this is already set up where x equals is already lined up. So our first thing that we need to do for substitution is take one of the equations and solve for one of the variables. It's already done. So then what am I going to do? I'm going to substitute that into the other equation. Now, I don't know if I could really call on people on this. You just got to watch and do. It's hard for me to say, okay, what next? And then you go through the steps of solving. You know what? We're just going to go. We're going to roll with it. So instead of graphing, we can do the substitution method. So just take a look at that again real quick. Second equation plugged into the first one. Wherever there's an x, you plug in that whatever x equals in its place. So you must have one of the equations solve for one of the variables, and then substitute that. I already forgot. I heard someone clicking. Can you tell me what 14 times 24 negative is? What's 14 times 24? It's like, I think it was 300. 336. I was about to say that. I can't believe I remember that from last hour. All right, and then you have to add 336 to both sides. I know this ends up working out. And then on the right side, you got to combine those y's to be 39y. 46, 351, and then what is 351 divided by 39? What'd you get? You didn't do it? You didn't get 351? I thought you were clicking buttons on your calculator. Oh, 9. Okay, so you got y equals 9. All right, sorry, I'm not picking on you because maybe you were picked by the calculator. I just saw you hitting buttons there. So, all right, so then what do you got to do about that y equals 9? You got to plug it in, plug it in. You can plug it into either equation. This one is set up better for it. Plus 24. This is negative 27. That's nice. Negative 27 plus 24 is negative 3. Now, I demand this. Remember what I said. This is taking the place of graphing. So what we need to do is write this as a coordinate at the end. All right? And it is a coordinate. You got to get that, this gets weird with interval notation. Sometimes interval notation can look like this. You got to get that out of your brain. This is actually a coordinate. All right? And then what does this coordinate mean? And actually in both cases, what does the solution to the system mean? It is the only coordinate that makes both equations true. So I'll go back to our original one. Negative 4 times negative 1/4 is 1. 1 minus 2 is negative 1. True. And then when I take negative 4 into the second equation, negative 4 times 3 over 4, those cancel, and this becomes negative 3 plus 2 is negative 1. True. I can do the same thing with this negative 3, 9. Obviously, negative 3, 9 satisfies this because that's how I got the x coordinate. It will also satisfy this, and I won't bore you with that plug-in. It's the only coordinate that makes both equations true. That's why it's the system's solution. This one, I'm going to do elimination. Right? It is kind of close and would probably be good for substitution. What could I divide this by? Both sides. What could I divide both sides by? Negative 2, and then you can plug in for x again. But I'm going to go ahead and show elimination on this. This is what you need to do for elimination. You need to get everything on the same side that has variables. You could also bring the negative 12, but I kind of like the non-variables on the other side of the equal sign. It's one or the other. You get both equations equal to 0, and that would still work. And then the top one, I'm just going to switch the x into 3y. So I got these lined up, x's, y's lined up, equal signs, and then numbers on the other side lined up. Here's the elimination method. I'm going to stick with the top one. What could I multiply this top one by so that the x's would eliminate? What's the answer to that? 3, 2, 1. 2. And hope you remember this. So I multiply the top equation by 2. I distribute it all the way through, and then rewrite that new equation right below. 2 times negative 12 is negative 24. Don't stop short there. These are my non-mathematical people. Right? Doing the same mistakes over and over again. Whatever you do to one side, say it. Do it the other. Those that don't multiply the right side, you're back in grade school. Right? You're doing grade school mistakes that need to be cleaned up and stopped. It's on you if you keep making those mistakes over and over and over again. So I got a handful of people that don't do structured homework, and those lack of structures is what's causing your demise. All right? So we got to make sure we work on that. And that's why I try to emulate what you should be doing in notes. Like what I'm doing in notes, this is how your work should look like. And I still have people majorly lagging behind on that. Just a handful. Just a handful. And then I divide by 12. Okay, now, same thing. Take that y equals negative 3 and pick either one. First hour, I pick the second equation. This hour, I'll pick the first equation. As long as your math was solid on your first run here, it doesn't matter. You'll get the same x value no matter which one you plug it in. This is negative 9, right? Be able to handle what I do next. This is negative 9, so I add 9 to both sides. So I see that that's negative 9, and now I do my undos, shorten up some of my work. X equals negative 3. Interesting. Got negative 3 for x when I had negative 3 for y. We write it as a coordinate at the end. Okay? All right. I guess I really can't bother anyone too much here. And I think I'm going to go with the elimination method. You can leave this as what I said before. Make a choice. This one I'm going to do a little different than the other hour. I'll just get it equal to 0. So everything's on the same side. It's one or the other. But since that first one already has everything on one side, I'll leave it. The other one, I'll just add 2y. All right? So then we get 3x, plus 2y plus 8 equals 0. So all I did was add 2y to both sides, and then I wrote the right side on the left side. Should be able to handle that. So this is also an option. You can get everything equal to 0 as long as everything's lined up perfectly and on the same side of the equal sign. Okay, and I think you see what's going to happen on this one. But what do I multiply the bottom one by so that the x's cancel out? 3, 2, 1, go. Negative. But then you also see what else cancels out. What else cancels? The y. And by the way, negative 0 is just 0. So I'm not multiplying 0 by negative 1. You're gone. You're gone. Oh, no. I ended up with this. What? Okay, so put this as a general rule for any equation solving. But be careful on the next thing I show you. Anytime you lose your variables, and what's left over is false. What does that mean for the solution to this system? 3, 2, 1, go. No solution. That is a general rule for any equation solving. So you'd say that that equation is not solvable. But in this case, what does that mean about the two lines? What two lines never intersect? 3, 2, 1, go. Parallel. That means the lines are parallel. So that's why you got no solution, because you got no intersection. So it's a little different than solving an equation and you get no solution. It just means the equation is not solvable. In this case, there's something a little bit more. And then maybe a note to self. Put this off to the side. What if you lose your variables? This is a big condition here. This is specific to this thing that we're doing here. But you're left over with a true statement. What could happen with that? 0 equals 0, 7 equals 7. That's what could end up happening. Usually it's 0 equals 0 when this specific thing happens. Okay, now you got to be careful. I know what you might want to say, all real numbers is the solution. Is that what you were possibly thinking? Right? That's what this means in equation solving sense. But that's not what happens with this particular thing. If you say all real numbers, you're saying every single coordinate on this coordinate plane is shared as a solution between the two lines. It's not what's happening. These two lines are exactly the same. So they are a line and then a line right on top of that. The only solutions that they share is the solutions that are on that actual both lines. So what you have to say for this is not all real numbers. You have to say infinite amount of solutions. Because there's an infinite amount of coordinates that the same line shares that solves both of them. So there's a little minor change there. If you put all real numbers, I do have to take a half point off there for that, because it's not true, it's not right. And that's what we do, we mark not right answers. But we also cover so that you understand that. All right, so I took a risk. Here's my next time, fumble. Boy, we got a lot of fumblers here today. 10. All right, nice. Who do we got there? All the way in the back, Emma. Does the calculator get you much? I feel like you haven't been hit by the calculator too much. All right, so I'm going to do this by graphing, which is the absolute worst way to solve a system, but I took a risk. I wanted you to understand the same concept behind the scenes here. So how would I graph this this first thing? By the way, what is this a picture of, Emma? The first equation, what is that? Well, is it a line or a parabola? It's a parabola. I don't know if that's what you said back there. So what's the y-intercept? That's what last hour's person did first. What is the y-intercept of that parabola? Oh, I'm going to mark you wrong so quick your head will be spinning. You should say what? I'm really saying that because on a test, if you write, -7, I'm going to take a half point off. It's 0, -7. Then how do I find the vertex? That's the most important thing. Go ahead and do that with numbers. Perfect. And then what do you get? Let's see your calculations here. Ooh, let's see. So you have -2 over -1. Good, 2. And then I'll do the next calculation for you. You plug it in though, right? Right, to get y. So when we do this, we plug into, we'll do this super fast. And I'll mentally do the calculation here. Plus 2 times 2 minus 7. First one is 4 times -0.5, which is -2. This is 4. -2 plus 4 is 2. 2 minus 7 is -5. So I plugged in 2. I got -5. And then through symmetry, I know this is going to be another coordinate. Okay, so solving through graphing, the worst way to do this. But actually, I got a question that works out real nice. All right, next. Let's see if they're paid a 9. Nice, right in the same row there. We got Ryan back there. How do I graph that line? Where do I go first? You're going to get marked wrong so quick your head will be spinning. What is the y-intercept? There we go. And then what do I do for negative 2? Over which direction? Okay, and then I see what's going to happen, so I'm going to keep doing this. I'm going to keep doing this. Oh, so close. And then I go down 2 and over 1, and boom, shakalaka. So that's why this works so nicely. Actually, we can use a special word for what the line is compared to this parabola. It's tangent. I talked about lines of tangency before and how special they are in calculus. But don't worry about that. Worry about that I have a parabola and a line crossing at one and only one point. And that point is, it looks like 4 comma negative 7, which is the solution to this system. So yet again, behind the scenes, it's where 2 graphs cross, what the solution to the system is, if they do cross. So when I look over at this next example, we should know that this is a parabola and a line. I'm not going to write that. You know that you're dealing with a parabola and a line. And then apparently one thing that could happen is a parabola and a line can cross once and only once. But of course, what else could happen? What's the maximum amount of times a line can cross a parabola? 3, 2, 1, go. Twice. You can see it visually. You can see that this is a possible scenario. So therefore, I'd have 2 solutions that are unique. Or couldn't this also happen? How many solutions do they share? 0. Of course this could occur. So what's going to happen to you mathematically? The same thing that happened in the example where we had no solution. Or something a little bit different that does happen in your homework. Okay, so I could do substitution or elimination. Sometimes you have to do substitution the way a question is lined up. So I think in this first one, I am going to do substitution. I'm going to have to get my line equal to y. So I'm going to subtract 2x from both sides. And then I'm going to divide by a negative right now. So there I don't have to show too much work. And I'm certainly going to solve for y, not x, because looking at the other equation, I just got one little spot for y, and it's right there. So since y equals, I can go into the second equation, or actually the first one, and insert that in there. But be careful. Be very, very, very careful. X squared plus 11x minus parentheses. I'm inserting 2x plus 2 in for y, so therefore it must all be subtracted. You know, that's distribution. And this is what students don't do. This is what we get simple mistakes with here. I think last hour I did elimination. I really think I did. We ended up in the same spot here, though. When I distribute this, this is minus 2x. So 11x minus 2x is 9x. And then negative 2 plus 22 is 20. Exactly in the same spot we did elimination last hour. Okay. You should be happy if you get picked on this one. Student number 24, putting you on the spot. That is you, Haley. What multiplies to 20 and adds to 9? So that means x plus 5, x plus 4. Don't stop short and say that the answers are 5 and 4 for x. That's on you if you do that. The whole MA process is to unfoil. And then what does that mean x equals, Haley? Oh, what does x equal? You made the mistake. Oh, no, that's not the mistake. What does x equal? If x plus 5 equals, there you go. So you made the mistake where the MA numbers ended up being the solutions, and they're not. You have to use the zero product property. Okay, we don't know the other answer yet. So I also heard you say negative 5 comma 0. Not true. I wondered what x equals, though. But guess what? I'm going to focus on this. And by the way, this is always what you should do. When I give my x's and it's a line and a parabola, you should insert the x's into the line. All right, it's easier, first of all, but in the future, it's a must. All right, when we have other things other than a parabola. I don't want to get into that, too much, though. And I'm going to go ahead, I don't know why that came up, and plug it into my new version of that y, because then this becomes really easy to evaluate for y. So that I solve for y. So I'm going to plug in x into this one, and then I'll get my answers right away. 2 times negative 5 is negative 10. Negative 10 plus 2 is negative 8. Don't lose who came up with who. When I plugged in negative 5, I got 8. I don't know what's going on. I got programs opening left and right. I guess my finger hit the screen. Get out of me, Mr. Samulus. All right, and then y equals, I think you got it here, be faster than me. Yep, got the thick one there. 2 times negative 4 plus 2. That's negative 6. So when I plug in negative 4, I get negative 6. So 2 coordinates, that means you have this second picture, something like this occurring. And that should make total sense. Okay? So plug the x's into the linear if you have that option. I only have 2 left, and I'll show you how easy these actually become. Oh, this is funny. I asked this last hour and nobody got it right. Obviously, these are 2 parabolas. Which way are these? Both of these parabolas facing? Is it up or is it down? 3, 2, 1, go. You're all wrong. So it's actually what? Down. You know why? If I were to solve for y, the first thing I would do is subtract x squared from both sides, right? So it's actually y equals a negative x squared. Ha, ha, ha. You guys feel betrayed on that? But don't do that. Don't do that. This is perfectly aligned for which method? Elimination or substitution? Elimination. What am I going to multiply the bottom equation by? Negative 1. So this became infinitely easy, and this is why you want to do this. Not only does it get rid of the x squared, the most important thing is the y's disappear. That looks delicious. The girl's sipping her triple latte right in front here. For free, right? You got a birthday present from Mr. Samulus, didn't you? Greatest present ever. Not really. All right, minus 120 equals 0. I could tell this is going to be one of those where the parabolas only crossed once, or the parabolas only crossed once. So, okay, and obviously parabolas, they can hit twice. So here's one parabola, here's another. You know, that could be a way. These both go the same direction, though. But I wanted you to review what could happen with these parabolas. You still could have 2 solutions. You also could have 1 solution. Like you could have a parabola here and a parabola here. These are both going down, so that's not the case. But it's the same 3 possibilities. 2 solutions, 1 solution, or none. And it looks like this should shape it out to just 1. How many times does negative 15 go into 120? Did we get that answer? Negative 8. And then unfortunately, we've got to plug this obnoxious negative 8 into one of the 2 equations. So this is going to be a bit of a process here. Plus y. So I took the top one, plus 26. It doesn't matter which one. All right, this is 64, negative 80, and negative 96. Negative 96 plus y plus 26. And then we'll shorten this up here. 64 and 26 is 86, 90. So this is y minus 6 equals 0. So y equals 6. Ultimately, the answer is 1 solution, 1 intersection, and it is here. So it's more like the second picture, both of them going down. In some way, shape, or form, they're only hitting once. That could happen in many different ways. All right, and then remember, if I get something where I get no solution, I lose my variables, then there's no solution. Something else happens on your homework, though. I'm going to leave that for you to figure out. Can I do elimination? Yes or no? 3, 2, 1, go. Yes, who eliminates? Who is going to eliminate in one simple step? The y. So therefore, you do get rid of, one of the variables that are in your way here for solving. But then what you end up with this one is, let's get a student because I know what happens on this one. Kind of lengthy the second part. Last student, you almost got away with it. Isn't that Ryan again? Yeah, sorry, Ryan. All right, so Ryan, I'll keep going. Negative 104, 94. Is that negative 88? Is that right, everybody? X, Y's cancel, and then 149, 39, 32. Hey, Ryan. Are all of those divisible by a certain number? Yes or no?
11.
So, and I'm not going to divide by 11. I'm going to divide by what, Ryan? Oh, actually negative. And then, Ryan, what's 0 divided by negative 11 still? So, therefore, this is nice and clean now. 11 into 32 is 12, right? 132. And then it is positive. Whoops. What am I doing? What am I doing? All right, I was writing 132 again. What did I just say? 12. It's 12. And then this still equals 0. So anytime you have a common factor that's numerical and you're solving, just divide it out and get rid of it. All right, what multiplies to 12 and adds to 8, Ryan? So it's x plus 6, x plus 2. What does that mean x equals? There you go. Just make sure that we are doing that. If you stop short and say 6 and 2, you jacked up this whole question. Unfortunately, the last part is, and I'll just be quiet about it and leave Ryan alone and everyone else, is substitute each one of these. And this is the part that's a little bit tedious. Not hard, just tedious. All right, this is 36 times 2, which is 72. This is 6 and 36. 60 and 36 is 96, but negative. And then 17 over here. Same kind of solve as the last one. 72, 82, 89. So is that y minus 7 equals 0? And y equals 7? So I plugged in negative 6 and I got 7. You don't need to see this online anymore, my substituting and evaluating. But I know what happened. When I plugged in negative 2 in this position, you actually got the same answer. You get 7 again. It's kind of weird. Just going off of what we did yesterday or last hour. So we don't have to bore you online with inputting numbers, input, output, and evaluating correctly. Feel free to use your calculator. You don't need, I like doing mental math, and you should train your brain to do mental math so that you get numerates, and then things become easier for you. All right.